Today I will teach you about the data types available in Python. So here we have some types of data types, like we have text type, we have numeric types, we have sequence types, we have mapping types, then set types, then Boolean types, then binary types, then none type. So we'll see one by one. So first we go for a text type. So here we write as text type, and that is str. Okay, so str is standing for a string. Now here, whenever we type any of the variable, we don't specify the data type. Directly we write a variable name and we initialize with some value. Now based on the value, the particular variable will be assigning the data type. If suppose, now I'm taking some x value and I'm initializing with some string called hello. Okay, then I'm printing that x value and just run that. Now you can see you're getting the string called hello. Now if you want to find out the data type, because I have not specified any data type here, but I'm writing in a single quote so that I know that okay, there's a string because I put in a quote. But now I want to find out what is the data type for this because I don't specify any data type. So we have a function called type. If I write type of x, then just run this. Now you're getting it's a string type. Okay. So by default, based on the value, the data type is assigned for a certain variable. Okay. Then if I go for print of type of x, now here it is giving the str is of class type. Okay. So the x is holding some hello and its type is string and here it is a class type. Right. Now you can put the string in double quotes also. If I take x1 equal to hello world I'm giving and print that x1 and just run. So you're getting hello world. So both you can go for single quote or you can go for double quote. Suppose you want to just put an apostrophe in between, then I can go for like x1 equal to like I want to write something called teachers like this. So here you have a single quote and double quote, but here I'm terminating into double quotes so that this apostrophe, that is a single quote, whatever you are giving, should also be in the output. So if I write x1 and print, so can you see this one? So you get teachers. If I write print of x1, then you run this one. Now you can see. So I want this one also. So better you are going to put into the double quotes. So this is of text type, that is a string type. Or if you want to directly just provide the string type, you can take, let's suppose I'm taking x2 equal to, you can directly write string of directly you can write the value like you can provide something called hello. and you can do. So like this also you can do. So you can use directly the string function and you can provide the value. Otherwise, if you give like this also, by default it is string only. So either way, you can go for assigning the string value. So that is for the text type. Then you go for the numeric types. So I'll write the numeric types. Now numeric types we have integer, float, and we have something called complex to denote the complex numbers. Okay. Now, if at all I am giving something like y equal to some 10. Now we know that is an integer. Okay. So just I want to print that value. So print of y and just run this. You get 10 value. Fine. Now I want to print the type of. We have a type function I said in order to find out the data type, and I am giving the y variable and just say you're getting an integer type and it's a class type. Okay. So here also we don't specify any data type, but internally it has been taken as an integer type. If suppose I'm going for y1 equal to some 13.2 and I'm writing print of y1 and also I'm writing print of type of y1, then just run this and here you can see the value of y1 is 13.2 and it's a float type. Okay. Now if I go for y2 equal to, okay, here I'm going for some complex number. So print of y2 and print of type function. Okay, so whatever you're getting in type function that will be printed and you're passing the y2. Just run this one. Now you can see this is a value of y2 and it's a complex number type. So you have the real and imaginary numbers. Okay, so that combination is called as a complex numbers. So you're getting this one. So these three are coming for the numeric types. So integer, float, and complex numbers. Okay. Now, if you want to give directly an integer also, you can give by using the int function. Let's say I'm taking y1 equal to int of 10. And you're writing the y1 to be printed. And if I go for type of y1, it gives obviously an integer. So directly also you can specify so that at least you know what you are giving. Similarly, you can go for float and similarly you can go for the complex numbers. Directly you can give. Okay. Then suppose if I go for y2, I am giving something like float of 20.3. Then you print that y2. So you're getting that. And if you want to go for type of y2, then you can go for the float. Okay. Similarly for the complex number, if I take y3 equal to complex of 5 plus, then you print y3 and you print a type of y3 also. Now you can see it's a complex number. Okay. Then I'll just print off y, you can write 3. Okay, so that's also been printed now, right? Now these three are been working as a numerical type. Now coming to the next type, we'll see sequence types. So here I'll provide something called sequence types. Now for this we have something called list, tuple, and range. Okay, now inserting the cell. When you go for list, it's a collection of elements, and the elements can be dissimilar. Okay, so here I am going for, let's say, a equal to, the list notation is the square brackets. Like this, you need to put, this is an empty list. Now here, if at all I go for a number, comma, I go for a string, maybe x1, then I'll give in double quotes, that's a string. Then I can give a character. Then I can give some floating point number. Okay, so like this, you can go for any type of dissimilar elements. Now this has been called as a list where you need to put into the square brackets. Okay, then you go for print of a. We'll check. Now you got the one, the next one, y, and so forth. Now here I try to check what is the type, because I have not specified any type here. I'm saying it's a list. We cross verify whether it's a list or not. So go for type of a and print. So you can see it's a list type and it's a class type. Okay, so it's a combination of dissimilar elements, and when you go for list now, we can add, we can remove, we can delete some elements. Okay, so here list is called as a mutable object where I can add, remove some elements from the particular list, and here we can access the elements of the list based on the index numbers. If suppose I'm printing I'm printing like a of 0, so this 1 is the 0 index, then followed by 1 index, 2, 3, and 4 index. So I want to print the first a of 0 index. We'll try to check. Now it is printing 1. If I print a of something like 2, so my expected answer is 0, 1, and this one should be the answer for me. We'll check. Yes, you got. So like this, you can access the index numbers. Through index numbers, I can access the value. So this is one type of data type. Now coming to the second one, we have tuple. Now when you go for tuple, the elements cannot be modified. That means tuple is immutable. You cannot modify any elements once you have been created a tuple. So here I am creating like b equal to, now the tuple notation is a bracket, what you need to give, or we say parenthesis. Now here I can write something like, see here also dissimilar elements, x1, then some 8, some 9 point, some 4, some character, some string. Okay, so like this you can frame n number of elements. Then I want to print the b. Just check how it is going to print. Now here you can see the brackets, also the parenthesis, but when you go for list, the output you can see in the square brackets. So square brackets is for the list notation, and here this one is the parenthesis is for the tuple. Okay, now here also we go for indexing. If I want, let's say type, we check first what's the type. So I'll write print of type of the b. Okay, that's a tuple. Now just run this, get a tuple data type. Okay, where it is immutable, we cannot modify any value once it is created. Okay, now we have created a tuple and we are accessing, we have gone the type, and we can go for indexing here also. Like the list we have seen, no? 0 index, 1, 2, 3, and 4, like that. So if I go for print a of 0, so the expected answer is x1. So we'll try to check a of 0, not a, is b, right? Why it is giving 1? A was for the list, so it is 1, but we need to give here b, not a. Okay, so now you can see it has been changed to x1, this one. Now if I go for again print of b of some 2, 2 is the index number, so 0 index, 1 index, and 2, 9.4. Yes, 9.4 you got. Okay, so like that we can perform some indexing onto the tuple also. Now we have something called range, the third one. Now range is a function. So if I go for something like c equal to range of some 7, and I'm printing that c value, then I'm also printing the type, print type of c. Okay, we'll see what is the answer. Now 0 to 7 is the range. That means here when you go for range, it is applying n minus 1 concept. So 0 to 6, so totally 7 elements we can work with. And here the class is of what type? The range type. Okay, so generally this one we are using in the loops. Suppose I want to print the numbers from 1 to 10, so there I'm going to use the value. Suppose I'll show one here. Like if I go for I in range of, let's suppose 7, and here I am going to print I value. So we'll try to check how it is going to print. Now you can see 0 to 6 only you are getting. 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, and 6 index. So we don't get this one 7. Okay, so starting from 0 to 7, right? So 0 to 6 index only, n minus 1 concept we are going to print. Okay, so for this situation we can go for the range type. Now the next type we'll see the mapping type. Now here the mapping type is nothing but a dictionary. So when you go for any dictionary, we have the key and value pairs. So similar to that, we have a dictionary in Python where we are going to keep the dictionary as a key and value pair. So if suppose I want to create one dictionary, let's say I'm taking d equal to, now this is a dictionary notation, the flower brace. So I'm going for like name is a key. So you put a colon for separation the name and key and value, some xyz. Okay, then class, I'm keeping it as a BCA. Okay, so I'm creating one dictionary with two. One is the name and class. So name and class is key, and xyz and BC is a value for that. Then we'll try to check print of D. Now I can see the flower brace, which is representing a dictionary where name, key, and xyz is the value, class is a key, and so every name and key value has been separated with a comma. Okay, so this is first name and key separated with second name and key. Okay, Now here we don't go for indexing concept because the dictionary is unordered. Unordered implies sometimes you can get this key and value first and this key and value second. So there is no guarantee that you get in the same order what you're writing. But in tuple and list, we have a guarantee that whatever you're giving the same order you're going to get. So there we apply indexing, but here we don't apply indexing concept. So how do you extract the value in place? Here I'm going for print of name. Okay. Not name, where we need to give the dictionary name with the name as a key, name as the indexer. Name is not defined. So now you can see you got the XYZ an answer. So you need to give the key here directly. Okay, similarly, you can go for print. The D is for dictionary, right? Here I'm taken D, and here you give class. Okay, then close. Then you need to get the BCA. So like this, we cannot put 0 and 1. Okay. So this is about the dictionary where we can access the dictionary value by using the key as an index. Okay, I cannot use 0 and 1 because it's unordered. Then we go for the next one. We have set types. So here, we have set and frozen set. Two things are there. So where when you go talk about sets, the unique elements will be taken into consideration. Okay. So now here also the same thing, the flower base we are taking. So here I'm taking something called E equal to. I'm just going for the flower base, but here we don't apply any key and value. Okay. So I will take like a red, green, blue. Okay. Red, green, and blue. Now here I'm printing the variable called E, and we'll check what is the output here. Now here also you get flower base, but here we don't have key and value pair. Okay, so when you have key and value pair like this, then that is a dictionary. When you don't have key and value pair, then it's a normal set. Okay, now if I just give a duplicate value here, like I'm giving again red, we'll just check whether the duplicate value is printed or not. So it is not printing the duplicate value because the set contains the unique elements every time. Okay, now can we add any element to this? We'll just check. The same thing I'll take, or I will just copy this and I'll put in the next one. Here I want to add like e dot, there is a function called add, and in this I'm going to put something called orange, and we'll check whether it will work or not. Can you see here? You got the orange, green. So this is also not ordered. If you can see the output, my first value is red, second value is green, third one is blue, and fourth value should become orange. But you can see orange has got first, the green has come second, blue has come, the red has become last. So this is called as unordered. You're not getting in order. Similarly, you go for this red, green, and blue, you got green, blue, and red. This is also not ordered. Okay, so set is also not ordered. Okay, so here we can say that when you go for a set, we can add some elements, we can remove some elements. Okay, that means modification can be done. So set is mutable And the next one we have is the frozen set. Now when you go for the frozen set, I can apply the same thing, but here how to write is sum f equal to, I need to go for frozen set. Inside this I'm creating a set, like I'll write same, I'll take red, green, red, green and blue. Okay, then you close this function, then you print the f value. We'll check. Now here you got the frozen set with green, blue and value. Now can we add any element to this? We'll check. So just copy this. I want to add f dot add of some orange and print that f value. Now you got error that frozen set object has no attribute called add. That means the frozen set is immutable. Set is mutable. Mutable means you can modify, like adding or deleting or changing the value, but the set is supporting that, but frozen set is immutable. We are not going to change. Okay. Now if you see the type of this, we have created one set now. Now if you go for type, print type of this set, that is E, just click this. So you're getting what? Set. Okay, and the class type. Similarly here we write print type of the frozen set variable. Just click this. You can see it is a frozen set type. So these are two separate sets. Okay, so the difference is we cannot modify any value in the frozen set, like adding or deleting or modifying, but we can do in this set, normal set. Okay, now coming to the other categories, the next one you can go for Boolean type. Okay, you can go for Boolean. Okay, so we have a bool data type, right? For this, you know that we go for a true and false value. So here if I go for declaring sum g equal to true, t should be capital, and go for print of g, and you can go for print of type of g also, so that you can understand what type of it is. Okay, then just run this. So you can see the value is true and it's of Boolean type. Okay, it's of Boolean type. So if you can write either true or false, it's up to you. Okay, it depends on the requirement. Either you can write true or false, but you need to put the capital T or capital F. Just rerun that, you get the false value. Okay, so that's the Boolean type. Then we have the binary types. We have the binary types. Okay, now in this we have something called bytes. Then we have byte array. Then we have memory view. Okay, so these three things. I will see the bytes, the first one. So I'll take one variable called h equal to bytes of sum 6. Then I'm printing that h value, and we print the type of h. So here I'm trying to work with 6 bytes. Now for every byte you are getting this notation. 1, 2, 3, 4, 5 and 6 bytes. And you can see the type is also the bytes types, and it's of class. Okay, so this is one. Then we can go for the second one, that is byte array. So here I'm take h1 equal to byte array of some 6. Now here you can see the bytes, you can see the b as a prefix as a notation. Okay, then print of h1, then print of type of h1. Okay, now here you can see the byte array is holding the bytes. Can you see here inside the b, it is nothing but the complete thing. It's been the parameter for the byte array. So byte array is holding a number of bytes. So here I have given 6. 6 is holding 6 bytes. It has been holding, and you can see the class is of byte array type. Okay. Then we have a memory view. So I can write h2 equal to memory view of, I'm giving something like bytes of 6. Then print of h2, then print of type of h2. Now just run this. So here you are getting at this particular memory, the bytes number of 6 bytes has been allocated. This is the actual memory address. Okay, and this is a memory type, you can see. Okay, and you are giving a, and it's a class type. So this is working with the pure bytes, and this is working with the memory addresses. Right. Then we have one more type, that is none type. Okay. Now here, if you don't have any value to be initialized, so taking f1 equal to none, then print of f1 and print type of f1. Okay, so if you don't have anything to be initialized, then you can go for this none. Okay, so this is also one of the type, and here this none type is of class type. So these are few data types in Python. So I hope I've given some input on the Python data types in and how to work in a Jupyter notebook. So if you like this video, do comment, subscribe, and share it to your friends. Thank you.